Okay, you guys, so we are still using the quadratic formula. Now, sometimes you will not always get two real roots. Okay, so sometimes you will not get two different answers that are also two real roots. Okay, so we're going to do the quadratic formula on these, and you're going to get some different kinds of answers, but the process is the same. So if you guys think you've mastered the quadratic formula, go ahead and try each of these example problems on your own and check what you get at the very end. Okay, so this one's going to have one solution, which means you get the same answer two times, but this will be two real roots. Okay, so we'll talk about what that means. And in this one, we're going to get two imaginary roots. So possibly this I thing that we talked about earlier is going to pop up, but we'll talk about that when we get there. Okay. Alright, so let's get going. Alright, so first of all, remember this side must equal 0. So I'm going to bring the negative 25 over, which when I move it over, it will turn into a positive 25. So this will be x squared plus 10x plus positive 25, and now it will equal 0. Alright, so the next thing, let's identify our A, our B, and our C. So my A is the number in front of the x squared, which I don't see a number, so secretly there's a 1 there, so my A is 1. My B is the number in front of the x, which is a 10. And my C is the number without a variable, which is a 25. Alright guys, let's do the quadratic formula, which I bet you're humming that song I taught you in your head, aren't you? Alright, so this is going to be x equals the opposite of B. The opposite of my B is negative 10. Plus or minus the square root of b squared, so 10 squared, minus 4 times my a times my c. My a is 1, and my c is 25. And don't forget, it's all over 2 times my a, which is 1. Alright, you guys, let's start simplifying. So, I'm going to simplify what's in the square root first. Okay, so we're going to get x equals negative 10 plus or minus the square root of 10 squared. 10 times 10 is 100. Alright, now this one, the negative's attached to the 4. Don't you forget that, or the demon cats will get you. So we have negative 4 times 1 is negative 4 times 25 is negative 100. Alright, then all over 2 times 1, which is 2. Okay, let's keep going. I'm going to simplify down this 100 minus 100. So this will be x equals negative 10 plus or minus the square root of 100 minus 100 is 0, all over 2. Alright guys, let's talk about what the square root of 0 is. What times what? That is the same number will always give us 0. You guys are so smart. It is 0. So the square root of 0 is 0. So this is going to equal negative 10 plus or minus 0 all over 2. Okay, so what this means, you guys, one time I'm going to have x equals negative 10 plus 0 all over 2. And a second time I'm going to have negative 10. This time will be minus 0 all over 2. Alright guys, let's see what happens. So, negative 10 plus 0, so I'm going to add the numerators, then divide. So negative 10 plus 0 is negative 10. And negative 10 divided by 2 will give me a negative 5. So this is like negative 5 over, negative 10 over 2. Sorry. Alright, so again, negative 10 plus 0 is negative 5. Negative 10. Good golly, Miss Long. Negative 10. And then over 2, which negative 10 over 2 is negative 5. Or negative 10 minus 0 is negative 10. I'm going to squeeze it over here. All over 2, which negative 10 divided by 2 is negative 5. Holy hot dog, do you guys see that we did get two answers, but they were the same answer? So this means we have only one solution because we only had one kind of answer. There weren't any different answers, just one answer, the same one, negative 5 and negative 5. Now, this does count 2 times though. So it's one solution, but it counts as 2 real roots. And if you think back to our first section on polynomials, what this is called is a double root. Okay, so what is happening at the graph? When the graph crosses at negative 5, it will actually bounce off at the negative 5. So you guys remember, so I'll kind of demonstrate. Got 1, 2, 3, 4, 5. Okay, this is like when the graph would come down and kind of bounce off the 0. So at -5, the graph is bouncing off that. Okay, so we have a double root, so it counts as 2 real solutions, but it's only, or 2 real roots, but it's only one solution because we only got one answer. The same thing, which is -5. Alright guys, so this one has 2 real roots, -5 and -5. Holy hot dog, right? Okay, now again, this one is very similar, but this time we're going to get some imaginary numbers in the mix. So let's see what happens. Alright, you guys, the first step, this side must be 0, which it is, so we're good to go. Okay, next up, I'm going to identify my A, B, and C. Alrighty, so the A is the number in front of the X, which I don't see one, so secretly there's a 1 hiding out. The B is the 2, which is the number in front of the X, and the C is the number on the end without the X, so 3. Alright guys, let's get the show on the road. So the X equals the opposite of B. The opposite of B is -2 plus or minus the square root of B squared. So B is 2. So it'll be 2 squared minus 4 times my A times my C. So my A is 1 and my C is 3. And then all over 2 times my A, which is 1. Alright guys, let's start simplifying and let's see what magical things will happen. Alright, I'm going to start with my square root. Okay, so we have X equals -2 plus or minus the square root of 2 squared. So 2 times 2 gives me 4. Alright, and this minus sign is attached to the 4. So -4 times 1 is -4. And -4 times 3 is -12. And then all over 2 times 1, which is 2. Alright, let's keep simplifying. So X will equal -2 plus or minus the square root of 4 minus 12 is -8 all over 2. Holy hot dog, do you guys see it? There's a negative. Okay, so that means some imaginary numbers are lurking in the mix. So let's talk about how to simplify down the square root of -8. So you have to go back to when we were simplifying radicals to think about this. So first of all, to make this number positive, because we cannot work with it if it is negative. So the way we save it from being negative is an I is going to hop out. So an I will turn it into a positive 8. Alright, so I'm going to do a factor tree and I'm going to look for my pairs. So 2 things that go into 8 are 4 and 2. And 2 things that go into 4 are 2 and 2. Alright guys, let's see if we see some pairs, okay, which I'm going to go ahead and start simplifying over here. So X equals -2 plus or minus. Something's going to happen with my square root, I don't know yet, and then all over 2. So, do you spot any cute couples at the ends of the branches? So what that means, you guys, I am not looking at anything that breaks down. So the 8 breaks down, so I'm not looking at it, and the 4 breaks down, so I'm not looking at it. I'm looking at only the ends of the branches. So, do we see any pairs? Holy hot dog, I see a pair of 2's right here, and if you ever spot a pair, remember one number comes out for the entire pair. So this one will hop outside the radical because the 2's are going to go on a hot math date. And then my lonely single number, my 2, is going to stay inside the radical. So these 2 2's hopped outside the radical, but only one will hop out for each pair. And my lonely single 2 will stay in for the night, so it'll stay underneath my square root. Alright, and don't forget, we also need this I, which the I we put right here. So 2I. Guys, which is not wrong if you write it as I2. Okay, but typically the I we write second. So this is 2 times I, which is 2I. Alright guys, the last step is to simplify, which ignore this. This was from the previous problem. Alright, let's simplify this thing. So when we simplify, we want something that goes into this one, and this one. Do not simplify with the square root. You cannot simplify into a square root. Leave it alone or the demon cats will get you. So let's think, what's something that goes into 2, 2, and 2? Holy hot dog, you guys, that is a 2. So we're going to divide all those by 2. So X will equal -2 divided by 2 is a -1. Plus or minus 2I divided by 2 is 1I, or just I. I'm going to leave the 2 alone, I'm not going to touch it. And all over 2 divided by 2, which is 1. Okay, which really, you guys, anything over 1 is itself. So my final answer is x equals negative 1 plus or minus I root 2, which I'm not going to write the 1 in front of the I because 1 times anything is itself. Okay, so this would be my final answer. So you guys can leave it as the plus or minus, or if you want to break it apart, you can. You can say x equals negative 1 plus I root 2, or x equals negative 1 minus I root 2. Either way. Awesome job, you guys. That was a blast. So this one we got 2 imaginary roots. Okay, and the reason why I know that these are imaginary roots, you guys, see how they have eyes in them? That tells me that they are imaginary. Okay, and I have 2 of them. I have the plus version. Okay, that counts as 1 imaginary root because it has an eye. And then I have the minus version, which also counts as an imaginary number because I have an eye. So I have 2 imaginary solutions. And since this is a degree 2 polynomial, because that's my highest exponent, I have the same number of roots that equals my degree. 2 roots and my degree is 2. Same thing with here, you guys. Although we only had 1 solution, both of these count as a root. So I have 2 roots and my degree is 2. Same with the ones we did over here, you guys. So on this one, we had 2, I guess we need to look down here actually. This one, we had 2 real roots. We had 3 and 1, okay, which that equals the degree 2 roots, which equals the degree, which is 2. And they're 2 real roots because these don't have eyes. And then this one had 2 real roots. Although we had the funky radical in it, they each count as a real root. So all of these, you guys, even though we have different scenarios for the different roots you can get, all the total roots should equal the degree, which since all of these are quadratic, since our highest exponent is 2, okay, they should all have 2 roots of some sort. So a combination of real and imaginary. Pretty neat, right? Holy hot dog, you guys. That was so much fun.